Good morning, and welcome to the Sustainable Cleveland 2021 Virtual Summit. We would like to thank our host for the summit, the Cleveland Public Library. My name is Kathy Len. I'm the Sustainable Cleveland Manager, and you have joined the From the Ground Up Good Communities Start with Good Soil breakout session. Please use the chat box for questions or comments and for resources to be shared during the session. Our moderator for this session is Brett Joseph. Brett is Chief Operating Officer for the Center for Food Innovation at Oberlin. Brett?
Thank you, Kathy, and welcome everyone to this session entitled From the Ground Up, Global Communities Start with Good Soil. Just in way of a brief introduction to the topic, I would just note that there's 450,000 brownfields in the U.S., and this is just a subset of the number of sites that have soils with altered chemistry or physical properties or abused soils due to past human activities. In Ohio, these brownfields have been inventoried. And like I said, it's a subset of the total number of vacant lands in Cleveland that are between 10,000 and 25,000. It has been long recognized that addressing these problems of soil contamination, soil alteration is essential for the city's sustainable economic development. These sites quite often are contaminated to a greater or lesser extent, depending on where they're located and the past history of those sites. But these contaminants can include many that are harmful to humans. And here I'm speaking of lead, arsenic, hydrocarbon derivatives, soil or coal, oil, gasoline, and a whole variety of manufactured chemicals that are derived from production processes or from products. They can arrive in the soil through multiple pathways, including from the air, and they can be dangerous to humans through direct contact, through inhalation, or through consumption. So obviously, if you are in the position where you have a new site, you have an opportunity to develop it as a community green space, as an urban garden, this is obviously going to be a big priority to test the soil to determine whether or not you have a problem with contamination and then what to do about it. So this is an opportunity in the session to hear from some experts that can tell us about, the remediation process, the testing process, whether these soils can be remediated to improve the soils and to recover urban sites to grow local food. And, how this all pertains to the larger picture in terms of the public health. For you, the session, hopefully one of the big takeaways will to give you an opportunity to understand what the potential contaminants are that may be found in your soil, how you can test your soil, recommendations for correcting the problems, basically where you can obtain help to address these problems, both in the short term and the long term. Our speakers today will be Jakob Hamlescher, Urban Technician for the Cuyahoga County Soils and Conservation District, Maggie Rivera, who is an Extension Specialist with the OSU, Ohio State University's Extension in Cuyahoga County, and then Logan Walter, who is a Regional Educator with the Central State University. We are going to hear from these speakers in that order that I just mentioned. While the presentations are being given, I invite you to post any questions that you have in the text box or jot them down as notes, and there will be an opportunity for questions and answers towards the end of the hour. I think what we'd like to do is hear from all three speakers before we get into questions and answers. If they're posted, I will read the questions back and we can take them in turn. So I will, in a moment, go to a screen share and hand it over to Jakob. But just a quick way of housekeeping, so that we don't get video or audio feedback, and that we can all clearly see the slides, I would ask everyone to, including those who are not speaking, to mute their video and their audio, and then turn them off when it's, or turn them back on when it's time to speak. I will do that myself. And so I am going to go to the slides again and hand it over to you, Jakob. Give me a moment and I'll bring up the slides. Thank you.
While Brent's bringing up the slides, I just want to thank Brett and Kathy and Sustainable Cleveland for putting on the summit and inviting us all to speak today. I think what we have today is some pretty good base knowledge, and hopefully we get a lot of questions that we can answer, because we had discussed in a previous meeting that this was definitely an area that we feel a lot of people have questions on. So hopefully we can answer what you have questions on.
Okay, hopefully everyone can see the screen. So take it away, Jakob.
All right. I'm seeing the sustainable slide. So my first slide was just an introduction slide. Yeah, I was Jakob Hamlescher. Here we go. Jakob Hamlescher. I'm going to talk today to you about why to test your soil, and what to be looking for. Also, just going to go briefly over what is in soil, what makes a healthy soil. I'm an urban technician, like Brett said, with Cuyahoga Soil and Water. I've been there for 1.5 years, but I've been working in the environmental field in Cleveland since 2014 in various roles, and also in Chicago. Just a little brief history on Cuyahoga Soil and Water. We have been, we're founded through the USDA, NRCS, after the Dust Bowl, to help with soils. And then eventually we moved into soils and water. And really, healthy soil is the way to manage stormwater, in our opinion, one of the major ways. So soil and water fits really well together. Brian, if you could advance two slides. So what is soil? If you could advance the next slide, please. So this is a basic breakdown of a healthy soil. We know that working in urban environments, we don't always necessarily have access to healthy soil, which usually it has to be built because of whatever environmental degradation has occurred on sites, whether that's overdevelopment or dumping or a myriad of other issues. But I'm seeing that it's not coming up with the words correctly, but it's roughly 45% mineral. So that's what you think of broken down rocks, or clay or other things. 5% organic matter, and then 25% air and 25% water. So you really want this fluffy medium that is filled with nutrients, but also has a fair amount of organic matter that helps break down. If you can advance to the next slide. So soil is alive, and I'm going to be talking about what we're testing for. A lot of times we're testing for the life in the soil. Healthy soil must have life in it in order for anything to grow. If you don't have a mixture of fungi, bacteria, earthworms, insects, protozoa, nematodes, small animals, mycorrhizal fungi, nothing will grow in your soil medium. It's of utmost importance to make sure that your soil is full of life. And a lot of times we see burnt out soil, what I like to call burnt out soil in urban areas, because the life has just been sucked from it, from growing, something as simple as growing a turf lawn and not feeding organic matter to the soil every year. If you're not leaving grass clippings, sticks, leaves, that sort of stuff, nothing can grow in the soil because there's nothing to feed on. There's just this thin layer of roots and grass that kind of form almost a green pavement that we see in a lot of urban areas, and that keeps water out of the soil, that compacts the soil. These are all things that we're trying to avoid. If you could hit the next slide, Brent. So what are we going to test for? There are several things you want to test for. We usually test for like biology, what's alive in the soil pH, what nutrients are available, and the harmful chemicals and other harmful things that might be in the soil. And sometimes those harmful things can be the biology of the soil. You can have pathogens and other things that are in your soil. If you could go to the next slide, please. So first of all, biology. So what's living in our soil? Like I said earlier, we want our soil to be a living medium. So if in 1 tablespoon of soil, there can be over 1 billion living organisms, from bacteria to protozoa, amoeba, mycorrhizal fungi, earthworms, insects, other microbiology, and even macrobiology. We have moles and other small animals that live in the soil. And without these, your soil isn't alive. And a dead soil, like I said earlier, is no good to anyone. So we're looking for beneficial life. You can see in the one picture, I have a picture of mycorrhizal fungi. This is very important to plants' growth for most plants, because oftentimes their roots can't take up all the nutrients they need, and they form a symbiotic relationship with mycorrhizal fungi that actually goes and seeks minerals in the soil and exchanges them with the plant through the root wall in exchange for some carbohydrates and other nutrients that the plant can provide for the mycorrhizal fungi. There's more and more research being done in this topic, and it's being found that this is actually one of the most important components to soil. Fungi is important across life. It is one of the original decomposers, and we need it plants need it in order to survive in soil, most plants. We also have beneficial bacteria. This is nitrogen fixing bacteria. And we can have pests too. This is a lesion nematode. You don't want those. They can cause various diseases in plants. So we're also looking for harmful pests that could be living in the soil and killing your plants and causing disease. On to the next slide, please, Brent. Mineral content and nutrient content. So plants also need nutrients. Like every living thing on Earth, you need to have certain minerals and organics to survive. And usually if it's an urban soil, it's been depleted and starved of organic matter for years. There's several different ways you usually send a test off and see what you have, but there's several ways you can fix it, whether with straight additives as used in traditional farming, or you can use a combination of cover cropping and mulching and composting to add these nutrients back into the soil with organic matter. On the top corner, we have a picture of some deep-rooted cover crops that help break up soil compaction. So cover crops can kind of have a dual purpose insofar that they not only add organic matter back to the soil when they die and decompose, but they can also help break up the compaction and add more space for water to be in. Next slide, please, Brent. Soil pH. It's also very important. We see a lot of times in urban soil that the pH is off because of, once again, years of neglect and misuse. A pretty good range for most plants is between 6 and 7, but that varies from plant to plant. You have some plants that prefer more alkaline soil, like I know asparagus prefers a more alkaline soil. And then you have some plants that prefer a more acidic soil, like I know blueberries like a more acidic soil than between that 6 and 7 range. But that's part of knowing what you want to grow. But in most instances, we're looking for a soil pH between 6 and 7. That is kind of the Goldilocks range for the majority of things that want to grow in the soil. And so we want to make sure that we are hitting that range. Next slide, please, Brent. Finally, we're going to talk about the harmful contaminants in the soil. Living in an industrial city, this is definitely something that we pay close attention to because we've had years of environmental issues, whether that's through it precipitating out of the air from smog or dumping. like Brett said, that there are multiple brownfields in the area. And these can be even things like abandoned gas stations, abandoned processing facilities. A lot of times things happen on the soil on the property that we don't know of, that could lead to these harmful chemicals. So the big three that the reason you want to test for these is obviously because you want to know whether or not you need to remediate your soil. A lot of plants can uptake these harmful nutrients, and then they can cause obviously issues with health issues for humans and animals that are eating it. Lead obviously has, for young children and people of all ages, has developmental and neurological side effects. It can be extremely harmful. For arsenic, we're in one of the areas in the United States that has a super high concentration. While arsenic does occur naturally in soil, we have a much higher concentration than is safe. This is due to the industry of the area. And arsenic has been shown to be, it's a carcinogen, and it can cause other long-term health effects. And the same thing goes with cadmium. These are three things, but there's also other heavy metals and other compounds that are extremely harmful for humans to uptake. So there are several reasons you want to test your soil. Most importantly, we want to test for these harmful contaminants, but you also want to check out the biology, nutritional content, and soil pH to make sure that you have a healthy soil to grow in and that whatever you plant in there thrives. Thank you. I'll pass it on to Maggie now.
Hi, everyone. I hope you can hear me okay. It looks like my volume's working. Hi, I'm Maggie Rivera. I'm with OSU Extension. I'm really happy to be here today. I'm going to talk about how to take a soil test. So, Jacob gave a lot of good reasons you want to take a look at your soil. I'm going to go through kind of how you actually do that. And just to start with, I want to kind of give a metaphor, right? Taking a soil test is kind of like going to the doctor, right? It can be kind of a hassle, right? You got to schedule, you got to find your doctor's office. But once you get there, you can find out what ails you, and then knowledge is power. You can do something with that information. So soil test is the same thing, right? When we're looking at our soil, it's all about the knowledge being powerful for us. If you know what's in that soil, you can better manage your soil. And, if there's something harmful in there, doesn't mean you can't garden. It just means you know how to proceed with that site. So if we advance here. Okay. So your first step when you're thinking about taking a soil test is going to be to define the area. People who are on this call, you may be wanting to test your backyard, and that's okay because that is a very defined area, right? So you've got your defined area. I included this photo because a lot of times in the city of Cleveland, what we're testing is vacant lots that people want to start community gardens on. I should say that with OSU, we help to manage the community garden summer sprout program. So that has about nearly 200 gardens across the city of Cleveland. And each one, we test the soil before that garden can begin. So that's my experience in taking soil tests. I've taken a lot of them. So again, when you're looking at a vacant lot like this photo, what we need to do is think about what are we going to be growing on, right? Are you going to be using that whole area, or are you maybe just going to be using half of it? We really only need to test the area that we're going to be breaking the ground in, right? The area that we're actually going to be working with the soil. And to help define your area and also to understand historical use, you can use the Cuyahoga County My Place website to help you do that. Brett, if you go ahead and advance. So this is the same lot, but just looking at an aerial view. You can see that whole span of land we were looking at is actually 4 different parcels. Okay, so there's 4 vacant parcels that we're looking at. So looking at it from this angle helps you with a few different things. First of all, it helps you kind of see the actual, legal city boundaries to that parcel. And if you advance just once, it also helps you kind of figure out what the historical use was. So sometimes, not always, but sometimes you can kind of glean some idea of what was on this vacant lot before maybe there was a house demolished, right? That's something we see often. So you can kind of see the pattern of the houses on this block are really towards the front of the street. So the likely scenario is that on one or, most of these lots, there may have been a house at the front of the lot, okay? So that gives us an idea of historical use. And that's important when we're taking a soil test because, again, it's that historical use that actually, contributes to that contamination. So if there were houses here, those houses may have had lead paint that may have chipped, and that's what may have contaminated the soil. Okay, so it also helps us define these kind of smaller zones we might want to test. If you advance, Brett, 2 times, one more, there you go. So it kind of defines these areas of historical use, right? I would suggest in this case, we would take a sample, a soil test from the front of the lot where the structures may have been. And then we might also take a soil test from the back of the lot where it may have been mostly grass, backyard, maybe a garage, or maybe some driveway. But again, mostly, it's been trees, shrubs, grass for quite a long time. All right, if you want to advance again. Just a quick little reminder, especially if you're testing in your backyard, front yard, side yard, you definitely want to call 811 before you dig. So you definitely don't want to be putting a shovel into the ground and running into your electrical utility, right? That could be very dangerous and also expensive to fix. So you want to call 811 so the utilities can come out and they can flag the different lines going to your house. This is less of an issue in vacant lots because there's usually no utilities running through. You can go ahead, Brett. And go one more too. There we go. So your next step in taking a soil test is to choose your lab. There's a lot of different certified labs that you can work with. Some are private, some are public institutions. And OSU has a fact sheet that kind of details quite a few, probably upwards to 20 labs you can work with in Ohio and surrounding areas. So you could choose any one of those labs, but if this is your first time taking a soil test, Penn State and University of Massachusetts, they are labs that work very often with the public. So these are 2 that we recommend because they are so good at working with the public. If you have questions, if you need help, they're very responsive. So if it is your first time taking a soil test, you may want to work with one of these just to start. Okay, so we can advance. Okay, so we've chosen our lab that we're going to work with. Say we choose Penn State. The next step is just to gather our equipment, right? So what you're going to need is a clean 5-gallon bucket and maybe a hand shovel. And then you're also going to need a plastic sandwich bag or what they call a soil kit. So we said we're going to work with Penn State. Penn State is one lab that actually will send you what they call a soil kit. And the soil kit contains a form and a paper bag. So like pictured on this slide. So that paper bag, it's just like a coffee bag. They're going to send that to you. Okay. Some other equipment is either a soil probe, and I understand not everyone has a soil probe laying around, and that's okay. If you don't have one, you can use basically a full-size shovel, and if you have really nice loose soil, you might be able to use a hand shovel as well. Okay, all right, we can advance. So what you want to get when you're taking a soil sample is you want to get kind of a soil core which is what you call it if you're taking it with a soil probe. And if we're using a shovel, it's more like a soil slice. Okay. Ideally, this is 6 to 8 inches of soil. This is based on how far the roots go, right? When you're growing a plant, roots of that plant are typically about 6 inches deep. So you usually want to get that because then you're taking the nutrient profile of that depth. So you can use it for planting purposes. In our urban soils, they tend to be very compacted. So if you can't get 6 to 8 inches, 2 to 4 inches will do, especially if you're just trying to figure out if the soil is has some of those things we're looking for, like lead, arsenic, and cadmium. But this also is telling you something about your soil already. If it is compacted and you can only get that shovel in 2 to 4 inches, you know, it's going to be pretty hard to grow in ground. So already you can start making your plans for constructing kind of raised beds and kind of building up on that soil. And if you can't get the shovel in the ground, even like an inch or two, you know, this is an indication that your site is very, extremely compacted. This might be an indication that you want to find a new site because there's no way to really tell if that site is safe. Okay, and it's going to be extremely compacted and hard to work with. We can advance. Okay, this is just a demonstration, right? So if you have a shovel and that's what you're using, you don't want to make a huge shovel-sized hole in the site you're testing, and that'll become even more clear in a second. So what you want to do is you want to just slice with the shovel so that you're getting just a small, maybe 1 to 2 inch slice. Okay, this is just a little animation. Brett, you can click 4 times. So you're going to slice, on the one side, you're going to slice again, and you're going to slice on the other side, and one more time at the top. And if we just go one more time, it's basically just that center piece that you're going to lift up and out of the soil. Okay, that way most of the soil can stay in place and you really don't cause a huge disruption to the site. Okay, so it's just that middle core or slice that we're taking. Okay, if you want to advance one more. Once you get that core or that slice out, what you want to do is you want to discard the top layer. So you want to discard the grass and the roots of that grass or whatever plants are growing on that site. And it's really just that bottom piece that you want for the soil test. Okay, we can advance. And you're going to put it in that clean 5-gallon bucket you have, okay? So that's your first step. Okay, we can advance one more time. Okay, but that's just one time, that's one subsample, right? So across the entire site, that area that you've defined to test, we need to take 10 subsamples, okay? If you advance. So again, if we're potentially wanting to grow on this entire site, these 4 parcels, we've already determined that there's kind of this backyard zone and there's this front yard kind of house demo zone, right? So we want to take 2 separate tests. We know that already. So if you advance one more time. So we've got it, separated into 2 halves. We're going to take 2 separate tests. But within even just that backyard zone, we have to take 10 subsamples, okay? So what we just did with our shovel, we're going to do here at this blue star, but then we're going to repeat that 9 more times, okay? So if you start advancing, Brett, you'll see the pattern, okay? So we're going to keep testing, yep, across this site, and we're going to test every kind of corner, right? We're going to get the corners, we're going to get the middle, we're going to get the edges. You want to move in some kind of logical manner, though, so you can kind of remember where you've sampled already. And again, this is why you don't want to take a full shovel size, because if you took a full shovel-sized hole of soil, you'd end up with more than a 5-gallon bucket of soil, okay? So this is kind of the pattern you want to look for. when you're sampling. Again, 10 subsamples for that testing zone. And what we would do is basically, well, I won't even go there yet. Let's advance. So you're going to take all of those samples. Each time you're going to put it in this 5-gallon bucket. You're going to mix it up with maybe your hand shovel. You're going to mix up the soil all together so it's kind of consistent and broken up. You can advance one more. And then at that point, you've got all of your subsamples. You've mixed them up. You can basically fill your bag. So again, you're filling that bag that the lab sent to you, or you're filling your small, plastic sandwich bag, and you're filling it with about 1 cup to 2 cups of soil. That's all they need to run their tests, and it's more than they need to run their tests. So that's what we do. You can advance one more time. Then you have it. You could package it up, close your bag. Then you have to kind of fill out the form. Again, every lab is going to have some kind of form that they have associated with their soil test. If you advance one more time. The thing about the form that's really important is to know that the lab has different codes for the different types of things that are being grown, right? And this is so that they can make recommendations for you. So if you're just going to grow grass on the area that you're testing, you want to make sure you put that lawn code. But if you're growing fruits and vegetables, they will typically have a code specifically for growing, home fruit and vegetables. And then you're just going to mail it. You're going to mail it to that lab, and they're going to do their thing and send you some results. We can advance. That may have been my last one. Yeah. So that's how to take a soil test. And I'll let it be handed over to Logan.
Good morning, everyone. Thank you for being here, and really excited to be talking with all of you and the Q&A after. Next slide, please. So one of your major heavy metals that you may find in your soil would be lead. So this is an EPA chart diagram that shows kind of a progression from 0 to 1,000 parts per million lead and what you might want to do with your soil, depending on what levels you found in your soil test. So 0 to 100, you're perfectly safe with lead. What I mean perfectly, I mean you can do any type of gardening you want. You can eat the produce. Your kids and your pets can play in the soil and in the garden, and you're fine. Above 100 parts per million, you start getting into a little more of a management zone where you need to start mitigating some of the potential risks and exposures. So between 200, 300, and 400 parts per million, you might want to start doing things like container gardening, raised beds. You want to start to shy away from root crops because root crops have the highest potential of any vegetable to have lead contamination on the surface of the roots. So if you do have heavy metals of any kind, make sure that you're washing your root crops especially well, and also washing any soil particles that might be on the surface of leafy green vegetables like lettuce or kale. Also, you should be, if you have higher than 100 parts per million lead, you definitely want to be washing your root crops really well and then peeling them. So that can really help mitigate any potential lead exposure or other heavy metals that might be on that skin of the root crop. Over 400 parts per million, you're starting to get into a more serious situation. You definitely want to always keep the soil covered and protected. You don't want loose dust particles causing issues. And one of your biggest exposures to lead or other heavy metals with soil is breathing it in. And so definitely be careful with that. So you don't want to be doing a lot of heavy tillage with your root.
Hey, Britt, how are you?
I'm doing well. Are you just?
Sorry, do you go by Britt or Brittany?
I go by Britt. No one calls me Brittany. But,
well, that's what I saw, so I just thought I'd ask.
Yeah, but
Excuse me, I'm hearing whoever is speaking, please mute.
I thought I'd come in and just sort of make sure I have down the shared screen portion of this.
Okay, sure.
But I can't figure out where to go to find.
Can this other person hear us?
The PowerPoint.
I'm not sure.
Linda and Brittany, we can hear you.
Are you guys sharing your PowerPoint separately, or is it like one big PowerPoint?
I thought I was was running.
Stand by,
Do you
everybody.
Do you have the green room open on a tab?
Kathy emailed me that she was still.
Oh,
raising
maybe
my
that's the
hands.
problem.
Shut that tab.
There we go. Okay, thank you. That's what it was.
Okay,
All right,
thank you.
sorry.
Back to you, Logan.
Yep, sorry everybody. I didn't realize that was going to happen. So anyway, so going back to 400 parts per million soil, this is where you want to be doing something like container gardening, raised beds. You want your soils to be probably 8 inches deep, and that I'm talking about new soil that you would bring in. So go ahead and advance to the next slide. We're going to go in more detail here. Okay, so 0 to 100 parts per million, like I said before, it's safe to do any type of gardening. So 100 to 200 parts per million, you're getting into a little more of a potential risk there. So grow your root crops and leafy green vegetables in raised beds. That's what I would recommend. Make sure they're 8 inches deep so that those roots aren't getting into the contaminated soil beneath. Wash and peel all your root crops, and then use reduced or no-till practices so that you're not stirring up the soil, getting the soil particles into the air and then breathing that in. That's not safe for you or your children or pets. Also, you may consider keeping the kids out of the garden, especially if you're actually still growing in the soil, but using these other safe practices. Next slide, please. So 200 to 300 parts per million lead. So I would only recommend to grow fruit crops, including fruiting vegetables. So for those of you who don't know or aren't sure about the question, is a tomato a fruit? Yes, it is. So a tomato is the fruiting part of the tomato plant. Peppers are a fruit. The pepper is the fruit of the pepper plant. Squash, melons, watermelon, cucumbers, all of these are fruiting vegetables, and these are safer to grow in more heavily contaminated lead soils as well as other heavy metal contaminated soils. The reason being is that it's hard for heavy metals to pass from the stems and leaf tissue into the fruit portion of the plants. And so basically there's kind of like a dam, a biological dam that prevents those heavy metals from getting into that other part of the plant. So seeds, even bean pods, pea pods, those are also safer to eat in heavy metal contaminated soils. Once you get to 300 to 400 parts per million, I really, at this point, I would not necessarily recommend growing food crops unless you really, really want to, again, keeping to the fruit crops at this point. And you can also just choose to use perennial ornamentals and also maybe just keep a lawn at this point. And do not disturb the soil as much as possible because those soil particles are going to have that heavy metal on them. And then I also would just recommend bringing a new layer of topsoil onto the site. This is an expensive step, so you can also even go to the extent of removing the top inches of topsoil off the property just because they're so contaminated. And oftentimes heavy metals accumulate in the top surface. And so depending on recommendations on soil testing, and also I would recommend working with Cuyahoga Soil and Water Conservation to determine what best practices you should use going forward to determine how deep the contamination goes, whether it's worthwhile trying to actually remove that contaminated soil, and then and looking for sources of new topsoil to bring onto the site and compost as well. And then container gardens, as well as if you're into aquaponics or hydroponics, just use that space as a growing production space, not necessarily directly into the soil itself if it's too contaminated or you're concerned for your health. Next slide, please. Yeah, and so 400 plus, this is where you really have to decide whether you want to lease, use, or purchase that lot for urban ag, and you may just want to go with a soilless based system and or container gardens at this point. If you do decide to go forward and bring in topsoil, I would recommend at least 8 inches, and also be aware that the topsoil that you bring in is going to settle over time. So plan for like 12 inches, which will eventually become 8 inches or even less once it's fully formed and settled. So just be aware that these are options, but they're very expensive to bring in new topsoil or remove existing topsoil. So if you have grant funds or if you have your own financial resources to do so, go ahead. But always be looking for more regulatory resources as well, because there's there are laws that basically control how you can dispose of that contaminated topsoil. Something else you can also do, if it's just a few inches of contaminated soil on the surface, you can rototill that in deeper and actually dilute the parts per million lead. But however, that is spreading the pollution into a deeper level of the soil. While it might help mitigate the concentration, it's still spreading. So I'm going to go ahead and tip my hat to Jakob over at Soil and Water to share with you guys, maybe in the Q&A, his opinion on that practice, because I'm curious to hear about it. Next slide, please. So this is a chart from the World Health and Food Organization. And so at the top, you can see the rows of arsenic and cadmium. So with lead, you're safe at 100 parts per million or lower. However, if you look at the top of the chart in that middle column, you see that arsenic should be at 20 parts per million or less, or cadmium should be 3 parts per million or less. So arsenic and cadmium have, based on this information, this chart, they have basically a higher level of toxicity. And so when your soil tests come back and you see 20, higher than 20 or 3 on arsenic and cadmium respectively, that's when you need to start doing those same practices that I just discussed with lead. So you can do a lot of similar practices to manage those. Next slide, please. So heavy metals. So lead and cadmium are different than arsenic. So I'm gonna talk about that real quick. So you want to keep your soil pH at 6.5 or higher. You can do that by liming. Again, you can also incorporate organic matter into the soil. You should do like 1/3 volume. So if you're tilling 6 inches of soil, you should also add 2 inches of compost or other organic matter sources. So organic matter helps to bind onto those heavy metals and prevent them from being released into the soil water, which then allows them to be basically drawn into the crops that you're growing, the garden vegetables. So organic matter helps to bind those and keep them out of your food. Keep up with phosphorus fertility. So phosphorus will compete with lead and cadmium in the soil water, so that if there's enough phosphorus, it's pushing that lead and cadmium away from the plants, basically. It's keeping them at bay. So keep your phosphorus fertility kind of moderate to high. And also don't over apply phosphorus. That is an issue with water pollution. So don't overdo it, but make sure that your soil tests are showing a good level of phosphorus fertility. Keep the soil well drained. Don't be trying to garden in lead contaminated or heavy metal contaminated soils where you have bad drainage, because a lot of water will cause anaerobic conditions, which can lead to those heavy metals being more available to the plants. Again, consult Soil and Water Conservation about diluting the heavy metals by rototilling. And then also there's the extreme measures of bringing new topsoil and or removing the existing topsoil to get rid of those heavy metals if the situation requires it. Next slide, please. So arsenic is a bit different. You can add organic matter to arsenic contaminated soils, but you don't want to incorporate it. So arsenic can be basically activated by higher levels of microbial activity. And so it's kind of like the opposite of good soil practices. You want to actually have lots of living things, but you don't necessarily want those living things to be allowing arsenic to be released into the soil. So my recommendation is to just apply it to the surface. Try to do no-till practices with your vegetables. So you can transplant into a leaf mold or a compost layer on the surface, and you should be fine with that. Avoid limings as much as you can, because you actually want to keep that pH of the soil at 6.5 or below. So lime can actually release arsenic into the soil solution. And some fertilizers with 10% higher phosphorus can be an issue. So this is the opposite, where phosphorus actually competes with arsenic for binding to soil surfaces. So phosphorus can kick arsenic off of soil particles and make it available to plants. So you actually want to have more of a moderate level of phosphorus fertility if you have arsenic in your soil. So make sure that you pay attention to what different heavy metals are on your soil tests, and whether you should be managing for lead and cadmium, or whether you should be doing other things to manage arsenic. And again, there's the dilution with rototilling and or bringing in new topsoil, removing existing soil. Next slide, please. So some really great resources online for you to look into more literature. Again, the Environmental Protection Agency, great resource. Cuyahoga Soil and Water Conservation District and their technicians like Jakob are a great resource as well. U.S. Department of Agriculture, and then University Extension Services such as OSU, CSU, and others are also great resources for information on managing heavy metals and soil health. Next slide, please. So just some general things. If you don't really have a lot of heavy metals in your soil and that really isn't a concern, then we can just kind of move on to general soil management. So adding organic matter is very important. You at least want to have a 2% organic matter to start with. So if you're below that, you really want to start heavily applying compost and other organic matters like leaf mold, wood chips, different things for organic mulches to help bring that organic matter level up. You want to add compost if your CEC is less than 15. So when you see a CEC on your soil test, that is cation exchange capacity, which is just a complicated phrase for saying nutrient holding capacity. So if your nutrient holding capacity of your soil is 15 or less, you want to add compost, which can greatly increase that. And so your plants will have more nutrient for a longer period of time anytime you apply fertilizers or compost amendments. And then again, make sure you're using organic mulches to protect the soil surface. Cover crops are another great way to mitigate some of these things. So legume can add nitrogen to the soil. So if you have low nitrogen, legumes basically grow bacteria on their roots that breathe in nitrogen from the air and then breathe out nitrate, which is nitrogen fertilizer that you would find in any lawn-based fertilizer or other chemical fertilizers. So basically, legumes are producing artificial or not natural forms of nitrogen fertilizer. Cover crop roots help to increase organic matter very drastically. And they can also help to reduce compaction by breaking up the soil with their roots. They help prevent soil erosion and improve drainage as well on the site. So very important to plant things. When you're not gardening vegetables, make sure that the ground's still covered with a living cover of some kind. So next slide, please. So the ideal pH for most vegetables is right at 6.5. Again, as Jakob mentioned in his presentation, there are some specific species that like different ranges, but basically that 6 to 7 is really ideal. And that also helps protect you from extremes. So a low pH or a high pH can release certain heavy metals into your soil, make them more available. So just pay attention to that. If you need to increase your pH, just add some lime. Always use recommendations from the product source and or extension services are a great way to also calculate lime application. And then use sulfur-based fertilizers to decrease pH if it's a little bit too high. Tillage, I recommend no-till or reduced tillage as a best practice. If you're not doing tillage, you're basically preventing yourself from breaking up all those mycorrhizal fungi. So all the fungi in the soil, which are an important component of the microbiology. If you're doing a lot of tillage, you're breaking up those mycelium and damaging mycorrhizal fungi and soil fungi. So again, reduced tillage is a great way to keep your soil healthy and help prevent the damage of soil structure. Deep tillage may, however, be needed right at first to break up some of those deeper compaction layers. So a rototiller, you can break up the top several inches of soil. If you need deeper compaction remediation, you might actually just want to wait for the cover crops to do that naturally, or you can get some heavier equipment. There are deep ripper plows and with deeper, they're called shanks, but they're basically just really deep implement pieces that will go through at 8, 10, 12 inches deep in the soil and break up even lower levels of compaction. If you have the resources or time for that, that's something to look into. Next slide, please. So these are the literature references I use. And again, I got my information from the EPA, USDA, Cuyahoga Soil and Water, and Extension Service websites. So make sure that you're looking into those yourself for further reading. And thank you.
Okay, sorry, I had to take a moment there to get back on the video. I want to thank Jacob, Maggie, and Logan for the excellent presentations. And in particular, just, as just a, one thing that just struck me was that this is the first time I've seen such a presentation where each of the speakers really addressed both the general soil management advice, very good advice about how to improve our soils, improve their functioning for plants and for, for thriving, high nutrition production in the urban gardening center. At the same time, talking about how to remediate and test and really gauge what is possible on the site given its its past uses and any contaminants found on it. So excellent to really understand that there are really two public health issues at hand here. One is how to improve the health of the soil and really nurture it back to life, and then how to address the inherent public health concerns that come from the possibility of contamination. Also, I want to draw everyone's attention, if you haven't seen that Kathy and others have put a number of links up in the comments that are just packed with information. Again, to summarize, links to OSU Extension, links to fact sheets from OSU that can be kind of ready sources of information. USDA, particularly NRCS, Cuyahoga Soil and Water Conservation District, and other information contained in the slides, which will be recorded, by the way, and accessible for later viewing. I want to open it up to any questions. We're at 22 past the hour. If there's any I would just simply ask that you unmute yourself while you're speaking, and then everyone else keep muted so that we don't get the feedback. So any questions that anyone might have?
If no one has a question, I can answer Logan's question that he kind of posed about tilling in. I would not suggest disturbing the soil at all. I think when you're dealing with urban soil, it's best to build on top of or remove it, which is so costly that I don't think most people that's a possibility for. So I would suggest layering cover crops and mulch and cover crops and mulch and cover crops and mulch.
Thanks, Jacob. I appreciate it. Something I'd read in the literature. Wasn't sure what you thought.
Yeah, no, we are very pro no-till at Soil and Water.
So I have a question, and this, I guess, probably should go to Logan. You described, I thought it was very helpful, to really quantify what would be advisable in terms of growing if you're between 200 and 300 parts per million lead, 300, 400 parts per million, or 400 and above. When would the test, well, I have a couple questions there. First of all, when would the test indicate that a regulatory requirement is being triggered? Also, related to that, what is the possibility of washing the soil? In other words, when is it triggering the need to bring in more advanced types of soil remediation measures, such as bioremediation or high, like heat treatment or other types of more expensive forms of soil remediation?
So I would say once you get to about 400 parts per million, that's where maybe more expensive, more extreme measures are permissible or advised. I would not. I believe what I've read is that I think 400 parts per million is limit for residential use purposes. Jacob, are you able to confirm that?
I believe you're correct.
Okay, so
I can't. Off the top of my head, that sounds correct.
Okay, so 400 parts per million. As if you're like a contractor, you're buying land and actually developing, you may be required to do mitigation if it's above 400 parts per million. If you're leasing the property from the land banks or purchasing that, that can also limit what you can do potentially. Once you get beyond that, like even 1,000 parts per million, you may actually be eligible for some brownfield remediation resources through federal and state funding. And so that's something where you can submit your soil test petition, work with Soil and Water and other local organizations to try and basically get your petition heard, as maybe you can get some remediation funding and assistance from the government. And then what else did you ask in that question that I might not have covered yet?
I was just asking about methods of remediation, like,
okay.
Yeah, both the regulatory question and then, for example, when would you be looking at, for example, bioremediation using bacteria or fungi versus using mechanical means of remediation?
Right. So bioremediation is effective. However, so there's two ways to look at it. One would be, are the microbes or plants binding that heavy metal to something, like either to organic matter or to the soil particles themselves? Or are you actually trying to extract, maybe you're basically harvesting plant matter that has absorbed those heavy metals out of the soil and then taking that somewhere else? I've seen there was a researcher in India that was using earthworms for bioremediation because they can bioaccumulate heavy metals out of the soil that they're basically feeding through. And then you can bait those earthworms and remove them out. So there's different methods. You're either trying to basically build organic matter to bioremediate through cover crops and organic matter applications, or you're actually like intentionally caring for a plant or maybe an arthropod species like earthworms to draw those heavy metals out and actually removing that organism over time. So there is that option as well. So that World Health Organization chart that I showed, where it showed 20 parts per million arsenic, 3 parts per million cadmium, and 100 parts per million lead, I believe that is the agricultural sales limit. So if you're a grower trying to sell produce and you're growing in lead contaminated soils that are above 100 parts per million, you may be in a situation where you don't want to be legally. And so while it's your choice to grow your own crops in your backyard the way you want for your own consumption, the consumption of your family, it's another thing to sell crops that you grew in contaminated soils. So that level of regulatory systems really kicks in once you start getting higher and higher. You can do all you want on your own property to mitigate the issue if you're above these required levels for sales, but it's a different thing as a grower and a seller.
Okay, we're starting to get some text questions here. Elaine Price wants to know, how can we address or take on wide-scale remediation across the city? And then related to that, and this is for anyone who wants to address that, Dan Brown asks, kind of building on that question, can you share insights into bioremediation? Talk about bioremediation is like I guess fungi-related remediation. Any further elaboration on that?
Can I add something here? Just to, I don't want people to lose hope or feel like this is just such an incredible thing that they might as well not even garden, because it's not. If you take that soil test, as soon as you get those results back, we're here to help you, right? So we can basically take your soil results and go through all that information that Logan went through so well, right? We can do that for your specific situation. And it's I think kind of a assumption that all of our soil is contaminated in the city of Cleveland, and it's not. So when we test vacant lots, more than likely they come back clear to garden. So don't think we only have contaminated soil and it's going to be expensive to remediate. That's not always the case. I just wanted to add that.
And adding on to what Maggie just said, and then to kind of move over to what can we do to address the citywide and bioremediation. At least in my experience, the most
microremediation. Sorry,
microremediation. Sorry. In my experience, and Logan and Maggie chime in if you have different experiences, but soil is usually dead. It's not full of contaminants, so it's more about, in my experience, bringing life back to the soil. And, that can be through cover cropping, through inoculating the cover crops with mycorrhizal inoculants that encourage mycorrhizal growth in the soil. As far as microremediation and citywide, Cuyahoga Soil and Water is actually wrapping up a study on cover cropping to remediate and to add organic matter and kind of bring back life to soil on urban lots. We tested a couple lots that we were inoculating a cover crop regime that we did over 2 years with mycorrhizal fungi. And the results have been pretty promising insofar as we're seeing a more biodiverse plant life growing. We're seeing a lot of weeds still, but weeds aren't necessarily bad. And we're, even if they're invasive, they're not ideal, but it's still better than, in my opinion, a turf lawn, which has shallow roots and isn't encouraging any sort of accumulation of organic matter. And, inoculants are a great way to add mycorrhizal fungi to the soil, if anybody else wants to build on that. And it's fairly cost effective and less labor intensive than some other things.
Okay, we're pretty much at the end of our session. There was one further question about peat moss. I think we'll need to defer that.
Can I just add just one really quick thing? The phytoremediation or mycoremediation, so specific to the actual contaminant we're talking about. So it's really important to have those results and talk to a professional about how, what is a strategy you're going to use, because it's not just one strategy cures everything.
Okay, and again, thank you for, it looks like we had around 30 or so attendees. Great session, very informative. Again, one final thanks to Jakob, Maggie, and Logan, and to all of you who are viewing. Best of luck in addressing these issues and being empowered with this information going forward. And enjoy the rest of the sessions today. Thank you.